Alrighty, guys, let's do a little bit more. So we talked a bit about martingales, how they related to derivative pricing, and then Don was asking about optional sampling and how one goes about using optional sampling to compute expectations of say stopping times or other variables that are interesting related to stock processes. Are there any questions or comments on this?
Could I ask a question about the homework 10?
Yes, yes.
Problem 1.
Hang on, let me bring it up. Yes, go ahead.
In this question, we don't have the payoff at time capital M, and also the forward start at capital N, and the F0 is determined at time 0. So I was confused about that.
Okay, let me see if I can help you. It says if we enter a forward contract, then we don't pay anything for it, and at time capital N, something happens. Right? We receive a zero coupon bond, and then we pay for it. So we try to write down from this text here, like what happens when the forward expires. Right? So there are specific dates in here. There will be a date M is equal to 3. And the forward contract is 2. This is the forward contract.
Sorry, Professor, I cannot see your paper.
Yeah, I need to switch it over to. That's better, right? Right. So so this is my time axis, and I have M is the this is when this is the zero coupon bond matures. And this is a forward contract, and this here is at time 0. This is when we're interested in the we want to figure out what this F0 is. Okay, so it's a forward contract on a zero coupon bond. And the zero coupon bond is what? That'll be B, in our notation, it'll be B of 2, 3, right? This is the price. This is the price at time 2 of getting $1 at time 3. Are you good so far?
Yeah.
So then the forward contract's payoff, so the payoff here is going to be the zero coupon bond. And then we have to pay for it. And we pay F0. So we're interested in, so f0 is set such that the value, such that the time zero value of the time in payoff B23 minus f0 is 0. Right, that's what a forward. This is a forward, right? It's not a futures. This is a forward, right? So f0, this is this constant that determines or partially determines the payoff. That constant is set such that the time zero value, so when we roll this value here over to here, you're going to get a 0. So what's the value of getting? So we need 0, and then we need to roll this back. So we need the conditional expectation, and we roll it. We get it at time 2, so we need to roll it back. So we need to roll it back 2 periods. Are you good so far?
Yes.
Right, so this is one equation in one unknown, and you solve for f0. So you need, there'll be 2 legs, there'll be 2 components. There'll be, so you have, so f0, f0 times this expectation of 1 over s0, 2. And then there's this one. So you need to compute this, and you need to compute B23.
Why S02?
This is, you get the value here. This is, you get the payoff. Here is time to payoff. Right? This here is the value at time 0 of getting B23 minus f0 at time.
Okay.
I'm not, so do you want me to calculate these 2 expectations here? We can do that. So let's work out what the first one is. So to get the first one, we need to know what the money market account dynamics are. So Sn plus 1, 0, this would be Sn times 1 plus, and then it's the interest rate Rn. Always keep an eye on the index here. This one here is not n plus 1. So what you get from this formula here is that this one here, this is actually Fn measurable. Because this is Fn measurable, this is Fn measurable. In particular, if I'm looking at S02, this would be 1 divided by 1 plus R0, 1 divided by 1 plus R1. And there should be a formula for how R1 is calculated. So you go back and you look at the formula for how R1 is calculated. Let me bring it up so you guys can see it. Right, so there's a formula for how R1 is calculated. It's up here. So if I want to get R1 here, I pick n to be 0. I get 1 plus R0 times epsilon 1 minus 1. Okay, so let's copy paste that into the sheet here. This here was 1 over, no, of course I forget again. This here was 1 over 1 plus R0 times this epsilon 1. And so if I want to take expectation of this ratio, I want to take expectation of this ratio, I'll get that this is 1 over 1 plus R0 squared times the expectation of 1 over epsilon 1. And this was 1 over 1 plus R0 squared times, what were the risk neutral probabilities? 0.5. And it will take the values u is 2, d is 1. So it'll be 1/2 times 1 over 2 plus 1. So this is going to give you the first leg, the first part, and then the second part is this one. How would we get the second one? Well, we need to remember what a zero coupon bond is. I guess zero coupon bond B23 is equal to what? So this is the price at time 2. This is current time. This is current time. Right, and this one here is expiry. And so the picture is, you're sitting here time 3, you're going to get your $1. And you want to know what this $1 is worth over here. So the way you do that is you compute the conditional expectation. You have to be measurable with respect to current time. So there's a conditional expectation of 2 here. And then you have your $1. And then you discount it back. So you can discount it back to time 0, and then you can move it forward to time 2. That's okay. So that will be that one. So now we're back to time 0. And then you move it forward. So this will be conditional expectation. So we have your S02 up there, and then you'll plug in what is the definition of S03 here. And that'll be S02 times 1 plus, and then again, you need to have 2 here. So this here becomes, you will cancel, you'll get 1 over 1 plus R2. So that was the zero coupon bond. And that was an important part of the leg that we're computing the price of.
The second part is a martingale, right?
Can you say that one more time?
I think the second part is a martingale. Yeah, to B2 3 and divide by S 02.
Yes, yeah. So you, in general, you will have B and M. This is a stochastic process that runs from 0 to M. That will be, so you're sitting here at expiry, you'll get your $1. And the value of that $1 at an earlier time, it would be B N M. And you would have that B N M divided by S0N. This would be a P tilde martingale. Yep. And the way that that comes to be is by having the B and M. This would be equal to the conditional expectation, just as what we had on the previous slide. And you get $1 at time M, so you can roll it all the way back to time 0, right? And then you can roll it forward to time N. So this will be roll all the way back to time 0. So that will be dividing here by S0M, and then you roll it forward. So now you're dividing here by S0N. This is what you have here. And then you'll pull this inside. You get 1 over SM0, right? And this is a Levy martingale. Does that make sense?
Yeah, so I mean, the expansion of the second part could directly be equals to B03 divided by S00.
Yeah, so if you are to compute the expectation of B0 M divided by S0, this would be directly equal to the expectation so that would be EN. So this would be the expectation of 1 over SM0. Yep. And this one here would be B0 M. Let me work out what this leg here is. So now we have an expression for the first part. Let me work out an expression for the second part. For the second part, what would it be? E tilde B23 divided by S20. We already figured out what the first one was. This was figured out what that one was. That one was here. So we get This is an expectation, 1 over 1 plus R0 squared, 1 over epsilon 1. That was 1 over S2. That was that part. So now we need the top part. The top part was my B23. That was 1 over 1 plus R2. I'm going to compute this mess. Okay, this part goes outside. And then what do we get here? This is 1 over epsilon 1. What do we get here for 1 plus R2? We need that formula we had in the, in the problem formulation. Bring that up. This was 1 over, so I want n to be 1 here. So this is 1 over 1 plus R1 epsilon 2. So this is 1 over 1 plus R0 squared. Expectation of 1 epsilon 1, 1 over epsilon 2, and then I need 1 plus R1 here, so I'll use the formula again in the problem formulation. This is 1 over 1 plus R0 times epsilon 1. So I can combine, I get 1 over 1 plus R0 to the power 3. And then I can use that they're all independent. So I'll get 1 over epsilon 1 squared, 1 over epsilon 2. I'm thinking that I have it. This is 1 over 1 plus R0 to the power 3. This was a half, and then this could be, what was it? U was 2, so this is 1 over 4 plus, and D could be 1, so that's 1 over 1 squared, that's a 1. That was that expectation. Then you get the other expectation is this was 1 over 2 plus 1, something like this. Right, and you want to solve this for your F0 right. We stop sharing so you guys can see it. What's the mass value? You want to solve this to be F0 times this expectation of 1 over S02. And we compute what that was. This was F0 times 1 over 1 plus R0 squared, 1 over 2, 1 over 2 plus 1. So that's your F0. There's this F0 that makes that one true.
I got it. Thank you, Professor.
You're welcome. What other questions do you guys have? Other questions do you guys have? So at this point, we talked about equity models. We talked about American options, and the last question here was about term structure model. I say we spend the last few minutes, or last half an hour, however much time you have left, to look at some foreign exchange. So let me go up to one of the foreign exchange problems. So there are a couple of foreign exchange problems. There are the first one is this one here, number 2. There's a new problem number 3 in the sheets that are up there for the exam. And the reason that there's a new problem number 3 is because the old problem number 3 was about Black-Scholes, and we didn't do Black-Scholes this year. This problem number 3 here, this is from an old lecture, the lecture we did last week. We went through this problem here. So if you want to see the solution to problem number 3, you can look here in the file, and you can also look at last week's lecture. There's a problem number 2 that we could do, which is about foreign exchange. And so let me maybe walk you guys through that. So this is number 2. You're given an exchange rate. So QN. This is the foreign exchange rate, right? So so you get so you convert say pounds to dollars by multiplying. Right, so we have the pound bank account. The pound bank account. So that would be the one that has the dynamics. We called it for M, and then we put an F up there for foreign. Maybe I could put a pound up there. M in pounds. It accrues with a constant interest rate. So you have the pounds that was in the previous period plus the pound interest rate. And you also have a dollar bank. So we also assume that there's a constant interest rate in the dollar country, the US. We just denote that by R. Right, so the randomness is here. This is where you find the randomness. It comes in the foreign exchange rate. So I can convert pounds to dollars by multiplying. So if I want the foreign bank account in dollars, I would simply just multiply. I would simply just multiply Q N times M N pounds. This is a dollar amount. Right, and the condition is the usual one, right? This is a dollar amount, and we know that anything traded denominated in the U.S. Bank account will be a martingale under the risk neutral measure. So we know that QN MN pound divided by MN dollars. This object here, this is a P tilde martingale. And that's what the question is about. So in particular, if I were to compute, ran out of ink, if I were to compute Qn plus 1 times Mn plus 1 pound divided by Mn dollar, condition on Fn, under the Grist-Neutron measure, I'll get nothing else than Qn Mn pounds divided by the dollar. But I know that these quantities here, D are non-random, it's Q that's random, so I know what these two here are. These are equal to, I can pull them outside. Pull them outside, I'll put Mn plus 1 pound here. I'll divide by the same thing. So I know that this equality sign is true, and I know exactly what the difference is between Mn and Mn plus 1. I'll be able to say that this is the same thing as saying that E tilde Qn plus 1 given Fn. This would be the same thing as Qn, and then I need 1 plus R coming from down here divided by 1 plus R pound coming from up here. And so in particular, you can see that, so Q, this is not a P tilde martingale. And that's what the question I was asking you, and figure out what this conditional expectation here is in terms of Qn and the two interest rates. Does this make sense? I should also say here that it's not only that that's not a martingale, but we also have that this is not a martingale. And for example, if I would start discounting by the money market account, this thing is also not a P tilde martingale. The thing that is a martingale is this one here. So you need to multiply onto the foreign bank account and divide by the domestic bank account. This will give you a martingale product. Any questions on this problem? I know it's getting late in the semester. Let's do one more little problem and then let's call it a day. I think you guys are tired. It's been a long semester. We'll just zoom in. Let me do one more. There's a little one more about. There's a little bit more about these foreign exchange rates. Let me share that one. That was number 6. Yeah, so there's one here. So again, you're given this interest, this foreign exchange rate Qn, and there's a binomial model for it. The expectation of these epsilons here, this is given to be 0.1. And so you're told that the domestic interest rate is 21%, and your job is to figure out what is the foreign interest rate in this model. Okay, so let's do that one, and then let's call it a day. So this here was number 6. You're given now a specific model for how the foreign exchange rate moves in time. So it's very similar to what we used to. You take the previous value and then you multiply on to 1 plus something. So here's epsilon n plus 1. And the assumption that has been given to you is that these random variables, they are IIDs, and they have mean 0.1. So the epsilon n's, the IID, and they have this mean of 0.1. You've also been given that the interest rate in the domestic currency is 21%. Okay, so what you know is what we just did. What you know is what we just did, right? This conditional expectation here is that ratio. Right, so from what number was this? This was number 2. From number 2, we'll have that this conditional expectation of q n plus 1 given event. This was qn 1 plus r divided by 1 plus r pounds. And our job is to figure out what is this r pound thing. But we can do that simply by working out, we have this assumption up here now. This is what we had in general. Now we have an assumption about these q's. So let's plug in what this is in this particular problem. This qn times 1 plus epsilon n plus 1 given fn. So this is measurable, so we can pull them outside. And then we'll have 1 plus, and now that's independent. We get the expectation of epsilon n plus 1. And we know what that was. That was 0.1. And we know what this stuff up here was. This was 1 plus r pound. And then you had your qn. 1 plus r was 21%. So this is 1 plus 0.21. So we are close to being able to solve for the foreign interest rate. We will get that everything we have here, the qn's will cancel. We will get 1.1 needs to be 1.21 divided by 1 plus r pound. And then you can solve for r pound. Are there any questions on this? Okay, guys, I think I'm going to stop here. I can tell you guys you've gotten a lot more quiet, and I don't want to burn you guys out completely. So let's just stop like a little bit early today. There are office hours again this week on Thursday and Friday morning. And then the exams are next week on Tuesday, and then the following week on Tuesday again.
If I have any questions that I can think of, I'll definitely let you know.
Can you say that again, Dawn?
If I have any like questions, I'm confused, but I'll definitely let you know.
Yeah, I mean, come to my office hours on Thursday and Friday.
Mhm.
The week that follows after that, it's not. I will not have office hours there.
Okay.
So it's Thursday and Friday this week where there'll be a time to.
Yeah.
Are there other questions or comments? Okay, then I hope to see you on Thursday and Friday morning, and if not, I will see you during the exams.